Hi, in this tutorial I will give an overview of LabVIEW LINX in combination with Raspberry Pi. So we will use the Raspberry Pi hardware, but in order to program and interact with the Raspberry Pi we will use LabVIEW and the LabVIEW LINX toolkit. So let's start with a short introduction. So here is what you need in this tutorial. We need a PC with LabVIEW and the LabVIEW LINX toolkit installed. We need a Raspberry Pi, and then we need some components like LEDs, etc. that we can connect to the general purpose input-output pins on the Raspberry Pi. And then we will use LabVIEW and LabVIEW LINX to establish a connection to the Raspberry Pi, and then we will create programs in LabVIEW that are running on the Raspberry Pi device. So what is LabVIEW LINX toolkit? LabVIEW LINX toolkit is a add-on toolkit that supports Arduino, Raspberry Pi and the BeagleBone platforms. I have used LabVIEW LINX in combination with Arduino in previous tutorials. In this tutorial I will use Raspberry Pi. So here you see how you can install the LabVIEW LINX toolkit. You just go to Tools in LabVIEW, select VI Package Manager. If this option isn't popping up in LabVIEW, you can just search for it in Windows. So VI Package Manager. If you haven't installed it, just Google it and install this VI Package Manager. And then by opening this software, you can install additional toolkit, and in this case we are going to install LabVIEW LINX. So then you just search for LabVIEW LINX, and then the NI LabVIEW LINX toolkit will pop up, and then just click on the install button in order to install this software. Next, a short introduction to the Raspberry Pi. So the Raspberry Pi is a small computer. It's low cost, and it runs the Linux operating system. And typically, in order to use Raspberry Pi, you need to install a special edition of the Linux operating system called Raspberry Pi OS. So before you start using LabVIEW LINX, you need to set up the Raspberry Pi. So you typically need to have a micro SD card where you install this Raspberry Pi OS. So typically this is what you need. You need a Raspberry Pi, this micro SD card, and typically you also need an adapter to use the micro SD card on your computer. You need a power supply for the Raspberry Pi. If you want to set up the Raspberry Pi, you also want to use a micro HDMI to HDMI cable, a monitor, mouse and a keyboard. So that's it. So typically these are the components or devices you need in order to set up the Raspberry Pi. So then next step is to install this Raspberry Pi operating system on the Raspberry Pi device. So then you just install this operating system on a micro SD card using a software called Raspberry Pi Imager. This is a small software that you install and download and install on your computer in order to install this Raspberry Pi operating system on the micro SD card. So when the operating system is installed on this micro SD card, you just put it in on the back on the Raspberry Pi, and then you just plug in the power supply, and then you will be able to run the Raspberry Pi operating system on your Raspberry Pi. So here I have connected my Raspberry Pi to an external monitor, a keyboard and a mouse, and then this Raspberry Pi operating system will pop up. So in order to remotely connect to the Raspberry Pi from your host computer using LabVIEW and LabVIEW LINX, you need to enable SSH. So you go into the Raspberry Pi configuration, make sure that SSH is enabled and click OK. Next, you need to have a wireless network connected between your computer and the Raspberry Pi device. So typically I set up in Windows a mobile hotspot, turn it on, and then on my Raspberry Pi I connect to this Wi-Fi network, and then when the Raspberry Pi is connected to this network, this device will pop up here in the list, because this list shows all devices that are connected to this mobile hotspot. So basically now your Raspberry Pi is ready to use in combination with LabVIEW LINX. If you need more help and more resources regarding setting up the Raspberry Pi and the Raspberry Pi operating system, you can take a closer look at some of my previous tutorials. So I have made several videos that are available on my blog and on YouTube. So I have made a tutorial called just Raspberry Pi, where I set up the Raspberry Pi and give an introduction to Raspberry Pi in general. And then I have made a tutorial called Raspberry Pi installation and remote access. So both these tutorials are available on YouTube and on my blog. Next, we need to configure and set up the LabVIEW LINX, so we are able to connect to the Raspberry Pi from LabVIEW and LabVIEW LINX. So basically you go to LabVIEW, select Tools, and then Maker Hub, and then select LINX, and then select LINX Target Configuration, and then this window will pop up. So here under Connection you just select Raspberry Pi. Here you select either the name of your Raspberry Pi, the host name, or the IP address. Then type the username and the password that you have created during the installation and configuration of the Raspberry Pi. And then when you click Connect, hopefully you will successfully be connected to the target, in this case the Raspberry Pi. So now you have established connection to the Raspberry Pi from the host computer, and then you will soon be ready to start creating your first LabVIEW application. Next, you need to install the LabVIEW runtime engine on the Raspberry Pi device. So then you just select installation and click. In my case, I already installed LabVIEW runtime, but for new user you have this install button, so just click install button, and the latest LabVIEW runtime engine will be installed on the Raspberry Pi device. So basically now we are ready to start creating your first LabVIEW LINX Raspberry Pi application. So now we are ready to start creating some LabVIEW LINX examples. So now I have opened my LabVIEW programming environment. I just go to Tools and select this Maker Hub, and then as remember we select this LINX Target Configuration, and then this LINX Target Configuration window pops up. I select Raspberry Pi, I select my host name or the IP address. If you don't know the IP address, you can go to where you have set up the mobile hotspot, and then you will find the IP address here in this list. Select username. Typically this is the default username is Pi, but when you have configured your Raspberry Pi you could have created another username. So in my case I have a username called Pi HPH like this, and I have a password like this, and then I just click connect in order to connect to the Raspberry Pi from the LabVIEW environment. And then you see successfully connected to the target. So now I'm connected to the Raspberry Pi that is running on the same network, this mobile hotspot I have created here in my Windows operating system. Next, I need to install this LabVIEW runtime on my Raspberry Pi. I have already installed it, but when you haven't installed anything here, this installed version will be empty, and then this button will say install. Just click on the install button, and then you're installing the LabVIEW runtime engine on the Raspberry Pi device, and then you are ready to start creating your first application. So then I can just click OK here, go back to the main LabVIEW programming environment, and then just select or create a project here. And then this create project window pops up. I select the blank project, click finish. So then this Project Explorer in LabVIEW pops up. Next, now I just select, right click here on project here, right click, select new, and then target and devices, and then I select links, and now detecting devices. Hopefully my Raspberry Pi is detected, yes, so then I just select Raspberry Pi, click OK, and now I have created a Raspberry Pi project here under this Project Explorer. Next, we want to make sure that this Raspberry Pi is working properly, so then I just right click on the Raspberry Pi here, click connect, to make sure that the connection between LabVIEW LINX and the Raspberry Pi device is working properly. And then after some seconds, hopefully it will be okay. And then deployment completed successfully, and then we just click close. This means that the communication with this LabVIEW LINX project in the LabVIEW are communicating with the Raspberry Pi remotely. Next, I can just click save. So here in my local hard drive, I have just created a folder called the LabVIEW LINX Raspberry Pi or something, and then I can just click save here, go to this folder, and just select a proper name for my LabVIEW project. I'll call it LabVIEW LINX Raspberry Pi or something. Of course, you can call it whatever you like, depending on what you are creating, and click OK. So now we are ready to start creating our first LabVIEW application. So then let's start with a simple digital out example. So basically we will use one of the general purpose input-output pins on the Raspberry Pi to turn an external LED on and off. So we will basically connect a LED using a breadboard, and then connect the LED to one of the pins on the Raspberry Pi, and then we will create a simple LabVIEW program where you can turn this LED on or off. So here you see the wiring diagram for connecting this LED to the Raspberry Pi. So we need a basic LED, we need a resistor, typically 270 ohm or something similar. We use this resistor in order to limit the current that are flowing through the circuit in order to not destroy the LED. So then we connect this LED to one of the general purpose input-output pins on the Raspberry Pi connector. This example I just used pin number 16, which is general purpose input-output number 23. So I connect this one to the LED, and then it goes through the resistor, through the LED, and back to the Raspberry Pi on one of the ground pin. So in this example I have used the ground, which is pin 34, like this. So basically this is the wiring. Next we need to create the LabVIEW and the LabVIEW LINX application in order to turn this LED on and off. So now we are back in LabVIEW and our LabVIEW project. So then I can just right click here, create new, and a new VI, like this. So here we have the front panel and the block diagram. So then I will just create start with the block diagram. I need to find this LabVIEW LINX palette, which you find here in the bottom, LabVIEW LINX. I just pin it and have it ready here. Then I select open in order to start a connection to my Raspberry Pi. Here I need to select local I/O. So this is the open LabVIEW LINX VI. Typically I need to use one of, also I have a close like this. So here we establish the connection with the Raspberry Pi, and here we close the connection with our Raspberry Pi. And then here under this palette we find different sub-VIs we can use. So now I'm going to just turn a LED on or off. So then I select this digital palette and then right. So this is a digital right, and this is the one we are using in order to turn LED on or off, or one of the digital output channel, either true or false. So then I just wire my blocks together like this. I can also wire the error output like this. So basically, now we are soon finished with our program. Next, we can start creating the graphical user interface. First, we can have just a Boolean button, which we turn either on or off, or I can use this one of the other buttons here. I can use this. Yeah, I can use this one. I can make it a little bit bigger, like this. So I will use this button to turn the LED either on or off. And then I can also use an indicator, so we can see if the LED is turned either on or off. So then, this is turn LED on. I could name this one. This one could be just LED status or something. That's all we need. Then we can, so we use this one in order to turn this LED on or off, like this. So this, if I click Control H, you will see all the inputs and outputs on the different sub-VIs. So then I start with this output value, which should be connected to this one, like this. So this is a Boolean value, either true or false. And then I next to specify the digital out channel. So then I can just right click here, create either a constant or a control. If I create a control, this one will pop up on the user interface. So here I can specify the digital channel I will use on the Raspberry Pi. I can select 16, like this. So then I just, so now this one is wired, this one is wired, and then I just wire this to this one. So then when I turn this on, this will turn on, and vice versa, like this. So basically, this is the basic application for turning a LED on or off. So then I can just save it. I can just name it LED or something, like this. Click OK. And basically, then I can just run the application, and now it's compiling and deploying this application down to the Raspberry Pi hardware. Now deployment completed successfully, then I can just click close, like this. Now I can, so basically this was our first LabVIEW LINX program that are communicating with the Raspberry Pi hardware, but we need to improve it, since As you see, in this case there is no while loop, because when you run this application it will stop immediately, and then we have never time to click on this button. So we need to select either true or false before we start the program, like this. But a better solution is to improve this, the LabVIEW program with a while loop. So then I just select a while loop here. I drag it over this part of the code, so the open and the close are outside the while loop, and then the digital write are inside the while loop. So then I can easily turn this on or off. So the next thing I need to include in the graphical user interface is a stop button. So then I can just find here under Boolean a stop button, make it a little bigger, remove the label like this. I wire it to the this icon on the while loop. In addition, we typically need to have a timer or something, so then just select a timer, wait, great. I typically want to wait for 100 seconds or something. Just also add this visible label like this. So basically, this is a simple LabVIEW program that are communicating and using the general purpose input-output pins on the Raspberry Pi. So let's now just start the application once more. It are deploying the latest version of the application down to the Raspberry Pi hardware. Deployment progress successfully. Click close. And now you see I can click LED turn on, turn off, etc. like this. And of course I also need to select the proper channel here, which was 16, like this. So here you see how the system is working. Here is my LabVIEW application running. Here's the block diagram, and here is the LabVIEW project. Here is my Raspberry Pi and the LED connected to the Raspberry Pi using this breadboard. So now let's just turn this to true, and then you see the LED is turning on, which you see here. Go back to my program, turn it off, and then you see the LED has turned off. So now I can just click the button, turn it on, turn it off, turn it on and off like this. So basically this is how you create a simple LabVIEW LINX application that are communicating with the Raspberry Pi. So let's see how we can deploy a LabVIEW application to the Raspberry Pi without having a connection to the host PC. So basically we will create an application in the same way, but then in addition we will build an executable LabVIEW application, and then this will be downloaded to the Raspberry Pi, and then when we are finished we can unplug or remove the connection between the LabVIEW environment on the host PC and the Raspberry Pi. So let's see how we can use the LabVIEW and the LabVIEW LINX to make this happen. So we are back in the LabVIEW programming environment. When the host computer is connected to the Raspberry Pi, we can have a user interface like this, and then we can interact with the user interface. But when we don't want to deploy LabVIEW application or a LabVIEW executable down to the Raspberry Pi without this LabVIEW connection, then typically we are not able to see the user interface. So then I will just make some small adjustments to this application. So instead of having this button turning on and off, I will just automatically turn the LED either on and off. I'm using this basic not feature in LabVIEW. So then I just use this shift register, and then in the beginning the LED should be off. So then I just set this to false, like this, and then I turn this one to this input of the digital write function, and then I just connect this not block like this. Can show the visible item. So now basically it's almost the same application, but now this LED is turned on and off not by clicking this button. It's happening automatically by the LabVIEW program, like this. So then first it's set to false, then it's changing to true in the next iteration, and then it changes back to false, etc. So let's just run this application and let's see what's happening. Basically, you see it's turning either on and off like this. I can also increase the wait here. Now it's 100 milliseconds, so let's say 1000 instead, 1 second. So then it's easier to see that the LED is turning either on or off, like this. Now it's turning on for 1 second, then off for 1 second, on, off, etc. So basically this is the application that we're going to deploy to the Raspberry Pi and make this application running without the host computer. So in order to make that happen, we go to the project, the LabVIEW project, select build specification, right click on the build specification, and then click new real-time application. And just wait a few seconds, and then this my real-time application properties pops up. Here you can specify a name for your application. I can just call it Blinky or something. Then target file name is always startup.rtxe for real-time executable. Then here's a local folder for the build, like this. And then next to the source file, I just need to select a proper start VI, and then this is the LED.vi, which is the application that we just created, and we need to select that one as a startup VI. So basically that's all you need to do. Click OK, save it, and then next you just right click here and click build, and then just wait a few seconds. And after a few seconds the build process is finished, then this application Blinky has been the build is complete, and you can locate it in this local folder. I just click done, like this, save my work, and then you see my Blinky application has been created here. And now I want to deploy this application so it runs on the Raspberry Pi at startup. So then I just right click on my Blinky application, select run as startup, like this, and now it's just going through a deployment once more. So now this Blinky application is deployed to the Raspberry Pi target. Deployment completed successfully, then just click close. And now the target or the Raspberry Pi device must be rebooted for the application to launch. Process with the reboot, then I just click yes. And now this application will start to execute on the Raspberry Pi. So basically now I can just close my LabVIEW application, because This application will run independently on my host computer, and it will run every time you plug in the power supply on the Raspberry Pi. So here you see the final results. So now this blinky application that turns the LED on and off every second runs entirely on the Raspberry Pi without needing a host computer or a Windows computer. So now I can unplug the power supply and put it back, and then the application will still run, because when the Raspberry Pi starts and the Raspberry Pi operating system starts, then this application will run as a startup application. So that's all for now. So good luck with your Raspberry Pi and the LabVIEW and LabVIEW LINX. Thank you and goodbye.